Hello and welcome to helpyourmath.com. In this video, we're going to look at an introduction to the inverse of a function. Let's talk about some concepts of inverse functions. So two functions, f and g, are inverse functions of each other. We're going to make this assumption. What is the relationship between the domains and ranges of the two functions? If they are in fact inverse functions, then the domain of one function is the range of the other function and vice versa. So for example, if 2 is in the domain of g, that is the, I'm sure f has more than just 2, is in the domain of g, then what that means is that 2 is in the range of f. What types of functions have inverse functions? We say that functions that are one-to-one have inverse functions. And a one-to-one function is a function in which every output has exactly one input. So the definition of a function is that every input has exactly one output, right? If I input 2 into a function, I shouldn't get 4 and 7. This is saying not only that, but we shouldn't be able to, it wouldn't have a function if there was one output that was received by 2 inputs. So for example, y equals x squared. You can get 4 as an output if x is 2 or negative 2. So therefore that function is not one-to-one, and therefore it does not have an inverse function. How can we determine if a function has an inverse function? There are two most common ways. One is by looking at the table of values if the function is finite, and make sure that no output values repeat. The second way is the horizontal line test. So you might remember the vertical line test, which is how we determine whether a relation is a function or not. The horizontal line test is we draw a horizontal line, and it should not intersect the function more than once. So it can hit it 0 times or 1 time. If it intersects 2 or more times, then the function does not have an inverse function. So no matter where we draw a horizontal line, it should never intersect the graph more than once. Let's look at some examples. So is this function, will it have an inverse function? The answer here would be no, because I can draw a horizontal line right here and it hits the graph in 2 places. So this no does not have an inverse function. Function. Okay, let's look at our next example. We have a table of values. We want to see whether this function has an inverse function. So we know it's a function because no value in the input repeats. However, I see a 2 here and a 2 here. It does repeat, so no, this function does not have an inverse function. Right, and if we go back to what it means, for it to have an inverse function or not, we would switch x and y, or in this case, x and g of x. And if we were to swap the values, then we would have 2 2's in the domain, which means it would not be an inverse, it would not be a function. Okay, in this example here, this is an exponential growth graph. Yeah, we can draw a horizontal line anywhere. And I know it looks like if I drew one right here, it's going to hit a whole, well, up a little higher, it's going to hit a whole bunch of points. But if we zoom in, you would see that all of those points are on their own separate little horizontal plane. This function would pass the horizontal line test. So yes, this function has an inverse function. Inverse function. Okay, so this one's yes. And our last example, we want to see if this one will. This is an emphatic no. There is nowhere on this graph that passes the horizontal line test by hitting a horizontal line once. If I draw a horizontal line here, it hits in 1, 2, 3, 4, 5, 6, 7, just even on the portion of the graph that we see. So definitely not an inverse function. No. Has no inverse function. And those are some examples of determining whether functions have inverse functions or not.